Now that we have the basics of titration under our belt, we need to go on and talk about the automation that can happen in a laboratory environment when it concerns titrations. And in this video, I'm going to show you a few different examples and then talk more detail about the specific model and the manufacturer that we have in the chemical technology lab facility. So first off, automation, automated titrations. Folks, titration's been around forever. It seems like, at least. So this is a common type of test that's done in a lab. So why not bring in an instrument into the lab facility that can automate this process for us and kind of take control? So that way, as it's titrating a sample, I can turn my back and I can do other things in the lab. And then I can come back to this instrument, which is an automated titrator, and then just kind of print off the report, see what kind of values or results that show up on the computer screen, and call it a day. So it does make my life much easier, at least we hope it makes it much easier. And it automates the process. And under the right kind of add-on features, we can even automate it more, so that way it can run all day long and titrate sample after sample after sample, and I do not have to be there to do it or touch a beaker or do anything at all until it gets finished. So this is just an example of a titrator. This is what I would call a standalone titrator. So a standalone titrator is often an instrument that does not get connected to a computer or to software. So a lot of times you have these touch screens that you can enter in your sample ID. You can enter in the mass or the volume of the sample that you've used. It can also display, and what you're seeing here in the picture is a titration curve for you, so you can ensure that that titration has went to completion before you stop the process or accept the results of that process. But a lot of the things that control the system really gets controlled here with the touch screen device. This is like the substitute for the computer and for the software on more, I would call, fancier versions of an automated titrator. Next up, we have the burette system, and the burette system will come in different sizes, and they will often be the center of the titrator. So they can range anywhere from 10 mils or 20 mil or 50 mil or 100 mil burette sizes. And these will get filled with the titrant that you are wanting to use for your lab procedure. And that titrant will often come from a bottle that's connected to it, and very often it is nearby, if not directly behind the burette. They will often keep these two things together, so that way you know what is supposed to go into that jug. Same kind of deal though. You still have to go through the process of standardization. You have to make sure that you calculate the correct concentration of the titrant that you are using through your lab experiment and key that value into the computer system, because very often it does not do that automatically. You have to do that as a user. So the same thing would happen with an automated titrator, just like a hand titrator. Number one, it does use a pH probe, and that's what you're seeing over here to the side. There's our pH probe. So that means it's got to be calibrated, and we often do that first. Number two, we load our titrant in, just like we do with the burette. And that titrant, we have to standardize it, which means we have to calculate the known concentration of the titrant that was loaded up on the machine. So the titrant bottle is filled. We go through a standardization process. I get data that's going to be numbers over here on the computer screen because it will do the calculation. I just have to do an average of those. And sometimes they will do the average too. It just depends on the type of model that you've got. Then that average is automatically fed or keyed in by the user into the software, so the machine at this point knows what to use when it begins to titrate your samples with. And then finally, number three, we'll then make our way to the samples with whatever we're titrating at that point. All right. Over here to the right-hand side, this is our large beaker. We do not titrate with Erlenmeyer flask. These are beakers, and the reason that they're beakers is because they give me a really wide opening. Erlenmeyer flask, they don't necessarily do this. They're very narrow up at the top, and these beakers are going to provide an area for all of the things that need to go inside actually fit. So that will include the pH probe, any other like temperature probes or any add-ons that you've got into that stir system, and then also the burette tip. So how does the titrant get inside of the beaker? So these are kind of the components that you will often see with any titrator that's automatic. It's just different models, different manufacturers, different ways that they look. So here's an example of two more manufacturer versions of automated titrators. Over here to the left, you're seeing that they have tried to simplify the actual pieces and compartments where they're doing the display read here on the actual main component of the instrument. That's also where the titrant's going to be loaded up here at the very top. A few controls here at the bottom that you can touch and make some setting changes. And then finally, over here on the right-hand side, you're going to see a pH probe that gets dunked down into a solution that's in a beaker with a little stir plate and a magnet. And the burette tip, of course, is going to go in there as well. To the right-hand side is Thermo Scientific's version of an automated titrator. So no difference. It's just everything's kind of built in together, right? Instead of separate pieces and parts. But all the basics are still there. So very often, a touch screen is going to happen here in front. That allows you to key in information of sample weight, sample volume, methods, pick methods, or whatever. The titrant will go here into the bottle. That titrant's going to get loaded up, and that titrant is going to get filled inside of your burette, which is going to be located here. And then from the burette, if you track the tubing lines, here is where you'll see it end up, and that's where our sample will go with our beaker and a magnet and the pH probe there on the side. So again, all TVs are made the same in a roundabout way. They all do the same purpose. They might look a little different. They come in different sizes. They have different features on them. But a TV is a TV, and a titrator is a titrator. Here's Mettler Toledo's version of a titrator, or at least one version of one. And again, they try to simplify the design so that way users aren't really confused, and it's very easy to train a new employee on, because it is a basic test that many people do on their maybe first day on the job. Who knows? But same kind of deal. We get a touch screen down here at the very bottom that gets loaded. The burette gets loaded with a titrant that has a bottle. It's not really shown here, but there's often a bottle that's going to be connected to this instrument that's off to the side. It's not in the picture. And then finally, that titrant gets delivered in drip, 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 drip portions into my sample that has a stir bar and a magnet on the bottom. All right. These, though, are not the titrators that we have in the lab. What we've got in the lab is from Metrome, and Metrome is what I would say, widely known company name for manufacturing of titration equipment, also on chromatography as well. So what we have in our lab at this moment are 7 what we call eco titrators. So these are like the basics of the basics. We don't need a lot of bells and whistles. We don't need a lot of the add-ons. None of that really matters to us. Our job as a program is to provide you training, basic training, on how to use instrumentation and do certain lab procedures, and this is one of them. So we just need you to go through the motions of calibrating a probe and standardizing a titrant and then titrating a sample with them. So we picked the eco titrators. They are the cheapest of the titrators. They do not require a computer. They do not require software. And just like all the other ones that you saw in the other pictures, this thing has a touch screen, and that touch screen you will use to pick your methods, to key in sample information, and so forth. Your titrant will be loaded into a bottle, and that titrant will load the burette, which is right here, and that will deliver titrant into your sample, which is here in the beaker, just like the other pictures with the other manufacturers. We have at this moment a total of 7 eco titrators. Retail costs, they're around $7,000 to $7,500 each. Again, they're not computer driven or software driven, so that price tag is for a full-blown system that's ready to use right out of the box. And these are very basic versions. So what we can do with these titrators are simple acid-base titrations. We do not have any other probes other than acid-base pH probes. That is it. That's all that we use these for. We have plenty of acid-base titrations that we can do with them, and we just don't venture out of that realm with our automated titrators. We do have what we call one Titrando, and a Titrando was ordered many, many years ago. This does require a computer. It does require software. So this is more, I would say, bell and whistly, a little bit more options with the Titrando. We have it in our lab. You're more than welcome to use it, but we like for you to start with the Eco Titrators first before you build yourself up to the Titrando piece a little bit later on in the program. When I say bells and whistles, well, what do I really mean? Well, what I'm getting ready to show you is an auto sampler. So these titrator systems can actually be as complicated as you want them to be. And if you've got plenty of different samples that you want to load up and you want to run those throughout the course of the day, then this is great for you. You can put your samples here, have them ready, so that way when the titrator completes one sample, it can automatically go to the next sample. You can also put different dosing units onto the instrument as well. So you can dedicate one burette with sodium hydroxide, one burette with maybe hydrochloric acid, one burette with potassium hydroxide. I mean, who knows? But you can have different dosing devices, and those different dosing devices are like different burettes, and those stay ready to go, and you can pick which one you want to use depending on what you need to titrate throughout the course of a work day. So just keep that in mind. What you're going to see with us are very basic models that really kind of involve you switching out the samples, keying in information, no auto samplers. You submit one sample at a time to the machine and let it titrate it. You get data and then you move on to the next. But like this woman is using here, you can load these up with multiple samples and have the system titrate throughout the day for you automatically, so that way you don't have to worry with them. A little bit of schematic about our Eco Titrators. This is what you're going to see when you go to there and when you go to our lab and actually use one for the first time. And like we've seen before, this bottle in the back, this is our titrant bottle. Very often we will have a titrant in here for you already. It's already going to be made. It's ready to go. We just need to flush out the old and put the new in, or a fresh portion of what's in the bottle. But we at least like to flush out the burette before we use it for the first time. And we'll talk more about that in just a minute. The touchscreen pad is where you're going to key in all of your sample information. It does not like gloves, so take your gloves off and then use the touchpad to kind of key in what you need to key in, and then put the glove back on. There's also a plastic shield over this as well. It just keeps it protected. We like for this to stay on unless you're actually touching the touchscreen, and then put the screen back on after you get finished with that. This green piece back here in number 1, that is, they call it a cylinder unit, but this is your burette. So this is what's going to hold your titrant, and it's also what's going to deliver the titrant. If you think about the way the burette is made, at the very end of the burette, you have a stopcock, and that stopcock often will lead into a tip of the burette, and that's actually represented here at number 9. So number 9 is going to be the tip of our burette, and that's actually what they call that. They call it a burette tip, and that's where the titrant will come out, and it will go into your sample. We have seen that this instrument performs better when that burette tip is out of solution. Do not submerge this into solution. For some reason, when we do this, it messes with the pH probe a little bit, and it can end a titration early. And we want to prevent those mistakes from happening. So the pH probe has to be submerged into your solution. That's correct. But we often find smoother, better results if we take our burette tip and hold it or position it above the surface of the liquid and allow it to drip down into the solution, just like we do it when we do a hand titration. Think about what we do. The tip of the burette does not get submerged into an Erlenmeyer flask as we titrate. We always keep it above the surface, and we always allow the drop to hit, and then we keep dripping until that color changes. The same thing is going to happen here with us. So when we titrate, we have the stir going, we have our solution getting ready, the burette tip, which is number 9, stays above the solution, and drip, drip, drip it goes into the solution as it titrates, and you'll get better data. All right. So number 1 is our burette. Number 9 is our burette tip. Number 10, they call this an amber glass bottle. We do use amber. Sometimes the titrants break down with UV light, and that can just come from light in the room, and sometimes it doesn't, but we often keep what standard is a amber jug that comes with the system, and we don't really change those out. But, you know, it's okay if you don't see amber here. If it's an acid, if it's a base, it is perfectly fine to do those in clear jugs. I mean, you've got clear burettes most of the time that you use when you manually titrate, so why can't we put this stuff in clear jugs? And we can, it's just that amber comes with the systems, and that's what you'll see most often when we begin to titrate these solutions with, all right? The other thing that I want to talk about with the instrument is number 14, and number 14 is an absorber tube. These are filled with little bitty pellets, and those pellets' job is to absorb moisture. So we do not want water to make itself into the amber jug that holds your titrant. That can very often lead to changes of concentration over a course of time, and we want to prevent these changes from happening as much as possible. So what goes on is that we put an absorber on, and that absorber absorbs all of the water or maybe contamination that can make its way into that jug and mess with our titrants a little bit over the course of time before we deplete it and before we use it all and have to refill it. So it just stabilizes the titrants for us from day to day activity. Next up, number 4 is our pH probe. That's exactly what we're going to be using here in our lab procedure. But this doesn't have to be a pH probe. It can be another probe, another ion-specific electrode. It could work or behave in a different way. We don't necessarily do acid-base every single time when we use these. But we're going to. But I'm not limited to that. So if I wanted to switch out a probe and do a different type of titration, we are more than welcome to do that with an automated titrator. It's just we don't have a need in our program to do something like that. So we save a little bit of money, we give you the training, we give you the introduction, and then that way you feel a little bit more comfortable when you go and get your first job working in a lab and having to use something like this. Next up, number 7. If you take a look at number 7, this is a threaded screw, and it's attached to a piece of metal. Number 7 is the clamping ring, and that's what they call this. So the clamping ring is almost like a safety guard for you. We don't want you to crash the pH probe into the bottom of a glass beaker because you can damage the probe. We don't care anything about you, but you can damage the probe. And if you damage the probe, that could be $1,000 or more that you have just ruined that we're going to have to throw away. So this is a safety ring. And what happens is that this slider will go up and down. So the slider is at number 5. That's called the electrode holder. And you push that red button and you can slide up and down that bar. And number 7, which is the clamping ring, is the safety feature. So that way when you lower that pH probe down into your beaker, you can ensure that that probe is not going to crash up against the bottom of the beaker and crack or destroy it. And it makes us feel a little bit better when you use it. So that's the purpose of number 7, the clamping ring. And number 5, because we do have to lower that probe into a beaker with sample before we begin to titrate. So number 7 prevents you accidentally damaging the probe. All right, so those are just kind of pieces and parts of the machine. It's just like a get to know me. I didn't touch about everything on there. There's no need to, but it kind of gives you a quick overview of how this instrument is going to work. If I take a closer look at the cylinder unit, which is our burette, what you'll find here, what I want to talk about, is actually number 3. And number 3 is our piston, and they call it with sealing lips. Ooh, piston with the sealing lips and a piston rod. All right, so the sealing lips and the piston can get wore out over time, as you can imagine. And what will go on is that it might not actually create a pressure system, really, that can deliver titrant, or the sides of the walls here can get damaged and it can begin to leak and not perform the proper way. As you can imagine, if this thing goes up and down, up and down, up and down, because that's what it does, it pushes titrant out. So titrant will leave out of the top, whoop, and then into our container that we're trying to titrate over to the side. So this thing is going to get filled with titrant, and that piston's head job is to move up and then push out that titrant out of the top. Well, if this thing is constantly going up and down, 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 up and down over the course of a day, you can easily see how it can wear itself out. So this is a consumable that can be replaced. It's something that you want to keep an eye on. Make sure that it's not damaged. Make sure it's not dragging. Make sure it's not leaking, because if that begins to happen, you are not really delivering the titrant that you think that you're delivering inside of the sample. And that's very important, because that's how your calculations are going to be based off of. So keep an eye on it. Make sure it doesn't get dry rotted. Make sure it doesn't damage over the course of time. These things last pretty long. They're meant to last long, but that is something that can happen with the burette area as you begin to titrate over the course of maybe months and months or years and years.